The future of the energy sector has always been associated with the need to accumulate capacities and use them as needed efficiently. Mankind is constantly looking for ways to conserve energy. Among them are lithium-ion batteries, gas storage, pumped storage hydropower, and gravity energy storage systems. All options have their advantages and disadvantages, so scientists do not stop looking for new technologies and methods. For example, to store energy literally in the sand. How can the world's first commercial sand battery installed in Finland be a game changer in green energy storage? Find out about it in today's video. The advancement of green energy, in particular solar and wind, poses several challenges, the most important of which is how to efficiently store clean electricity as the sun and wind cannot be turned at will. Definitely, it would be possible to build huge lithium-ion batteries as Elon Musk's company did for the Australian government in 2017. But such projects have many disadvantages. First of all, the cost of the battery. For instance, an industrial battery in Australia with an installed capacity of 100 megawatt costs the government about $50 million. Secondly, over time, the battery capacity will decrease to a critical level due to the limited number of discharge and charge cycles, and the problem of its disposal will arise. Gas storages are significantly less efficient than lithium-ion batteries, and the construction of time-tested, cheap, and powerful pumped storage hydroelectricity (PSH) requires a long construction process and a suitable landscape. The principle of operation of gravity energy storage systems is based on gravity and friction, just like a PSH, only without water. But the effectiveness of this new technology has not yet been studied. Therefore, while some scientists are working to create a cheaper battery and improve traditional methods, others offer alternative variants. According to research by the National Renewable Energy Laboratory (NREL), one technology that could help increase green energy storage is storing sunlight as heat. The principle is that concentrated sunlight or wind energy heats up a coolant, which is then used to power an electric generator. These heated materials can also be stored to generate electricity during cloudy weather or even at night. To extend the storage life of the converted energy, materials are chosen that can be heated to high temperatures and then retain heat for a long time, such as salt, stone, or sand. This technology outperforms lithium-ion batteries in the long term, as it does not lose capacity over time, can carry out an unlimited number of charge cycles, and does not require disposal. In recent years, various modifications of this method are increasingly being transformed from laboratory developments into real projects. For instance, Finland's Polar Night Energy Company recently launched its first commercial sand battery at the Vesienkoski power plant a few hours' drive from Helsinki. The battery is already providing thermal energy to the nearby town of Kankaanpää in western Finland. This thermal energy storage system looks like a 7-meter-high bunker inside of which there are about 100 tons of low-grade sand. The device is capable of storing 8 megawatt-hours of energy at a rated power of 100 kilowatts. Cheap electricity heats the sand to a temperature of 500 degrees Celsius due to the so-called resistive heating, exactly according to the same principle the work of electric fireplaces is arranged. The sand heats up the air which circulates inside the battery chamber with the help of a heat exchanger. Sand is great for energy saving as this material has a high heat capacity. That is, it heats up very slowly but cools just as slowly. According to the developers, the storage can keep the sand at a temperature of about 500 degrees for several months. When electricity prices begin to rise seasonally, the hot air from the accumulator is used to heat water for the central heating system. From there, heat is supplied to apartments and offices and even the local pool. As a country with a harsh climate, Finland's ability to accumulate a significant amount of green energy during the warm season, allowing it to lower the cost of purchased heat carriers and evenly distribute the load on power plants, is critical. The prototype of the sand battery was developed in a former pulp mill in Tampere, whose city council purposefully provided the site and provided the necessary funding for this. The Polar Night Energy claims up to 99% coefficient of efficiency. the ability to store heat with minimal loss for months on end, and a service life of decades that exceeds all other methods in every way. The installation cost is estimated to be less than $10.27 US per kilowatt hour. What is more, the system operates fully automatically using no consumables and with minimal maintenance costs. At the moment, the sand battery serves only one city, and it is still not clear whether the technology can be scaled. Some analysts believe that its efficiency drops when it comes to returning electricity to the grid. Despite this, the developers are full of optimism and intend to take the next step to create energy storage devices with a capacity of about 20 gigawatt-hours that can produce hundreds of megawatts of rated power. And in some specials designs, the sand will be heated up to 1,000 degrees Celsius. Obviously, no one doubts that the future of humanity depends, among other things, on the widespread use of green energy. Because with a constant increase in energy consumption, reducing costs as well as the harmful impact on the planet's ecology is the key to our survival in the 21st century. But clean energy, unlike oil, coal, and gas in each country, has its own face, as it uses the resource that the state itself has. Therefore, nowadays, we have an opportunity to observe a huge variety of energy supply systems, as well as renewable energy storage technologies built on local features of the landscape, climate, and mentality that do not destroy local ecosystems, rather supplement them. The sand battery from Finland is just one example. Without a doubt, in the future, we will see many other ways to combine natural resources and modern technologies designed to bring comfort to our homes and save the world around us.